Cosine is the adjacent side over the hypotenuse. In the case of the unit circle, the hypotenuse is the radius of the circle, which is 1. Here is a graph of the cosine function as it goes around the unit circle with a radius of 1. For cosine, it's going to be the x-coordinate over the radius, or just the x-coordinate since the radius is 1. Starting at 0 and going in a counterclockwise direction or a positive direction on the t-axis. The t-axis is the distance along the unit circle. This would be t. I start at 0 degrees, which would give me an x of 1. It begins at 1, and then as t increases, x begins to get smaller and smaller and smaller until it reaches 0 at 90 degrees. And that's what this graph shows. It begins at 1, starts decreasing until it gets to 90 degrees. Once it gets to 90 degrees, x begins increasing again, but in a negative direction, shown by this graph, until it gets to 180 degrees. At 180 degrees, x is equal to minus 1. Minus 1 divided by 1 is minus 1. So it's now at minus 1. X values begin decreasing yet again until it reaches 3 pi over 2, where it is 0. And then once more, it begins increasing. The x-coordinate gets larger and larger until it reaches 1, and then I've gone around the circle and I'm back where I started. That's the basic graph of the cosine function, and it goes the same in the opposite direction, or the negative t direction. In a clockwise direction, same thing happens, but just going in the opposite direction. Now I really briefly want to mention the transformations of the cosine function, which are exactly the same as the transformations of the sine function, which are exactly the same as the transformations in polynomials. This here is a vertical shifting. And it's just like when I had x plus 3 or x minus 4. I have the function value, and then that function value is adjusted by some integer value. It doesn't have to be an integer, but it's adjusted by some value, whether it be plus 1, plus 3, plus 4. So this would shift this whole graph up. If it was a positive number, by whatever that number was, up, and if it was a negative number, by whatever that number was, down. Here I have cosine x being subtracted by some arbitrary number. This is phi, it's being subtracted by some angle, and this is a horizontal shift. Very similar to something like y is equal to x minus 2, which is a shift 2 units to the right. And the best way to think of these is when something, this is the way I remember it, when something is subtracting the function value, it is delaying when that function value will attain that number. So if I delay it, it's going to take longer for the function to reach that value, so we'll shift it to the right. If I add something to it, it's going to shift it to the left, because it's going to expedite when the function reaches that particular value. But it obeys the same rules as the shifting for when I learned it in college algebra. This is horizontal compression and then stretching. If I have something like cosine of 2 theta, that means if I put in the angle, say 360 degrees, it's going to double it. So if I put in 360 degrees, instead of going around one time, I'm going to go around twice. So the graph will look like this. Well, not quite that badly, but here I went around one time and then I went around again, so I've gone around twice. So the graph has been slightly compressed. If I were to say cosine of 1/2 theta and go in a negative direction, then it's going to take longer for me to go around the circle. It's going to take 2 pi instead of just pi for me to go around the circle. So this is going to look like this. It's really terrible. So something like that, where the function has been stretched out. It's going to take 4 pi to go around. I'm 2 pi and I've gone halfway around. I still need to come up and over, and that will happen at 4 pi. And then lastly, a constant multiplied by the function value. This is going to be a vertical compression and stretching. Oh, whatever. Wouldn't delete it for some reason. But what that's going to do is I'm going to get my regular function values, I'm going to get my regular graph, and then it's going to be multiplied by some number. So if it's multiplied by 2, then instead of going between 1 and -1, it's going to be 2 and -2. It's going to stretch it vertically. And if I multiply it, say, by 1/2, then it's going to compress it vertically. Then the values will go between 1/2 and -1/2.